Whenever we write a value, we need to communicate how well we actually know that value. The language used to do so is the significant figure. Now, in this example, you see that we have a decimal written that has a leading zero and trailing zeros. Leading zeros are not going to be significant. And the reason for that, suppose that we put the unit meters after that. You can see that we could also rewrite that to be in maybe centimeters. So that would be 10 centimeters, 10 centimeters. All we've done is we've moved over our decimal place 2 places to do our conversion from meters to centimeters. This leading zero is just holding the decimal place where it belonged. If I write another zero in front, that doesn't actually give me any information. It's not wrong to have an extra zero right here. However, it's not communicating any knowledge. It's just communicating that I have an empty place. That's all that our leading zero did, and so it is not going to be significant. However, these trailing zeros will be, because they communicate that we actually knew it all the way out to 4 total places. So there would be 4 significant figures in this value. Now, for a whole number, our trailing zeros are not going to be significant for exactly the same reason as this one wasn't. It's just there to hold the decimal point where it belongs. Suppose that this were 100 centimeters. How many meters would that be? 100 centimeters is 1 meter. What we're going to have to communicate is, do we know it to be 1.00 meters, or are we just communicating that it's 1 meter? Well, in this case, by putting a decimal point right here, we're marking that it is significant. If we have nothing at all to communicate the significance, it means that these trailing zeros will not be. And so this will be the same condition. Now, there's other ways of marking it too. Sometimes we'll underline the value. We don't want to use an overbar because that looks like infinitely repeating from math. But some people will underline the value, but that can be confusing, so we rarely will use that context. You can also just write known to 3 significant figures. Or the really proper way to do that would be to convert it to scientific notation, where we say 1.00 times 10 to the, and in this case it would be 1 to the second. We can write it like that as well, and that'll communicate very reliably that it's 3 significant figures. But there are a few different ways of doing so, so make sure that you're communicating your sig figs in an appropriate way. I'm going to erase the ink again. Here we are. Now, exact numbers will have infinite sig figs, or you can think of them as having no impact on your sig figs. If you have 2 apples, you have 2 apples. There's not uncertainty in how many you have. If you know something well and there's 0 uncertainty, we have to communicate somehow that there's no uncertainty. Now, if it's obvious that it's going to be an exact number, 2 apples or 2 atoms, we don't need to communicate it any further. We'll also communicate times where there's an exact thing and that it'll have infinite sig figs. These will matter a lot when we do our propagation of error. Now, metric definitions are going to be exact quantities. In other words, converting from 10 millimeters into 1 centimeter. We're not gaining or losing any quality knowledge. All we're doing is looking at a ruler and saying we've moved over a few spots on our ruler, but the object stays the same length, and we're still measuring it with the same device. We're still going to have the same quality of knowledge. It's just a question of, did I communicate it as 1.0 centimeters, or did I communicate it as 10 millimeters? So exact definitions are not going to have implications on sig figs. There's also going to be a few conversions from English into metric and vice versa that have infinite sig figs. Most of them will not. The reason is that most of those historic units that we use in the English system are based off of some specific observation. And those have turned pretty esoteric in our modern world. How long is an inch and why do we pick an inch? Or a foot? It's obviously not the size of our foot. And all these other things. Centimeters have a much more specific definition, and in fact, we've actually taken most of the metric system all the way up to fundamental constants in the universe. Things like if I take a single hydrogen atom and I put energy into it and I get a light spectrum of light coming off of it, we'll find out about that later. This specific color is exactly this wavelength, and when we take that wavelength of light, one wavelength is this much distance, or this many wavelengths is this much different distance. We've actually gone that hardcore about making those distinctions. Most of the time we have not. Now, here's going to be an opportunity to do some practice. Go ahead and go to our next video and try out determining some sig figs.